Now we can turn our attention to avoiding an object. At this point, we have seen how we can use the IR sensor to detect an object, and now what we're going to do is we're going to combine that with a locomotion sequence in order to actually influence how our tracker moves across a field and can actually detect and avoid an obstacle. So what we're going to do is we are going to create a program, and it is going to take our tracker and move forward. And as it goes, it's going to continually look using its IR sensor for obstacles. If there's not an obstacle, it just continues forward. If there is an obstacle detected, and we'll say about 3 inches, we are going to take an action. So we are going to back up about, I don't know, maybe for a second. We're going to turn right, go forward for maybe a second, and then turn left, and then repeat. Now notice that I put this blue line. That represents a path that is being taken through our decision where there's not an object in front of us. So look at what we could do is that if we detect an object, we would then take an alternate path through our decision or our switch, perform the red obstacle or the red sequence, and then we can continue back with the blue and continue forward while we look for another obstacle. So the rationale of this is to gain experience using both locomotion and the sensors at the same time. Okay, so let's go ahead and fire up our Mindstorms software, and I'm going to go ahead and come up here and start a new project. And what you can see here is that I have my tracker, and I've set up a couple obstacles. So I've set up a couple books on my desk, and I want to make a program that will take the tracker, move forward slowly. When it sees this, it'll go back, turn, come over, turn, and then continue. And then if it works properly, it will also see the second obstacle, back up, turn, go forward, turn, and continue. And it will continue like this indefinitely as long as it's in this program. So let's go ahead. Another part of this program is, or this exercise, is reusing some of the things we've done in the past. So you may recall that we spent a little bit of time when we were looking at locomotion on how to make a perfect 90-degree skid steer. Well, we want to kind of remember the settings we had for that. So if you still have that project, it's worthwhile opening it up and actually remembering what the settings were to do a perfect 90-degree skid steer. In addition, we've also set up the IR sensor in order to detect an object that was, maybe a certain distance away that might be relevant for this task. So those are other good settings to check. Okay, so let's take a look at how we're going to get started. The first thing we want to do is go to flow control, and we're going to grab an infinite loop. So I put this up there, and I'm using an infinite loop because we're going to continually run this program forever. Okay, now I'm going to come down and I'm going to grab a switch construct. Remember, a switch is nothing more than our decision. And I'll go ahead and grab the pan tool here, and I will zoom down so I can see. And now let's set up the switch. So I'm going to come over here, and I am going to set up the switch to be sensitive to our IR sensor. And I want the IR to do a compare proximity. Okay, then I got to make sure that my IR sensor is on port 1, which is how we have connected it, and then we're going to use the less than, and then this threshold right here, it's kind of interesting because this threshold isn't necessarily a distance, it's a scale from 0 to 100, and what I'm going to do is I'm going to set it at 10%, okay, because I want it to get pretty close to the obstacle before it actually reacts. Okay, so now let's think about what we're doing with this switch statement, this decision. If you see an obstacle, you are going to go through this path right here. If you do not see an obstacle, we will go through this path. So let's set up the construct or the sequence of motion that we do when we don't see an object. So I'm going to come down here, and I'm going to grab a move tank block, and I'm going to pop it in here. And what I'm going to do is I'm going to slow this down because I want to have it move forward pretty slow. And what I want to do is I want to set this to just be on. Okay, I don't want it to go on for a second, move forward, and then stop, look around, and then move forward for another second. We want it to kind of continually move forward, so that's how you use the on setting. Okay, all right, so I've got it moving forward continually on, and what will happen is that when there's not an obstacle, it'll simply just go through this loop and decision. Okay, so now what I'm going to do let's set up the program for when we see an object. Okay, so this is going to be the sequence we're going to do when we see an object. So the first thing we want to do is we're going to do a move tank, but on this situation, we want to do it for a certain amount of seconds, because we're going to move back, then we're going to turn, then we're going to move forward, then we're going to turn. So the first thing we want to do is move back, and I'm going to set this up to 75, so I know I want to take a crisp action, and this is just a option, you can do it whatever way you want. And what I want to do is I want to move backwards, so I'm going to put -75, all right? -75, and that means that it's going to move both the B and the C servos backwards, which are attached to our track. And what we want to do is I'm going to actually leave it this time. I'm going to have it on for seconds, 1 second, and I'm going to have it break this time. So it's going to do a crisp backwards movement for 1 second. Now I want to turn. And I want to turn right, and I want to do a skid steer. So I'm going to go ahead and grab another move block, and let me go ahead and move this over a little bit. And what I'm going to do here is I'm going to recall that my really good 90-degree skid steer was when I had the motors at 75 and -75. So in this situation, if my left one went forward and my right one went backwards, I will turn right. And I remember now that if I put this at 0.8 seconds for example, that was about 90 degrees. And then I'm going to leave it as a crisp stop. So that was from my prior program when we looked at locomotion. So that should do a backwards for a second, turn right, skid steer 90 degrees, and now I'm ready to move forward. So I'm going to go ahead and grab this block, since I've got it all set up, and I will then move forward for 1 second, and I do that by setting this to +75. And +75. And now let me grab the pan tool, and I'm going to go back over here a little bit, pan a little bit. And now what I want to do is I want to turn left. Okay, so I'm going to go ahead and Control C my skid steer block, and I'm going to take this. And now in order to accomplish a turn left, I will change the directions of which ones are spinning. So we'll pop it in here. And at this point, I'm going to take this, make it -75. And I'll make this one 75. Okay, so now I have my left motor going backwards, my right motor going forward, and it will turn left. Okay, now notice that that's all I need to do. Let me zoom out a little bit so you can see the entire program. So let's think about what we're doing here. So when I don't see an object, I will move through this path right here, which is moving forward continuously at a pretty slow speed, and I will continually loop there. If I see an object, what I'm going to do is I'm going to back up for 1 second. I'm going to do a skid steer right for 0.8 seconds, which I assume is 90 degrees, based on a prior program. I'm going to move forward for a second, and then I'm going to turn left using a 90-degree skid steer. Okay, so this is where I'm at. I should be ready to test this, and so I'm going to go ahead and download, and there it is on my program, or on my brick. So I take this off, and I'm going to browse to, I should have renamed it something nice, but I'll go ahead and say program. Okay, so here I go, and I'm going to let this go, and let's see if it can detect the first obstacle. It sees it, back, forward, left. Okay, that worked pretty good. The skid steer seemed to work just the way it did before. Let's see if it can do another obstacle. Back, left, forward, or back, right, forward, left. Okay, great. So that seems to be working. That worked very well. Now we notice that we got it right in the first try on this one, and that's because we were reusing some of the settings from before. So that was pretty important, and that speeds things up. So it's kind of, you want to save your projects, you want to kind of save the settings on there, but this is working. Look at what we're doing. We are detecting an obstacle using an IR sensor. We are using it to cause our locomotion to react, and we kind of have a sophisticated program right here. We have a detect and avoid an obstacle program. And that is it. We've accomplished what we set out to do. So let's take a look at where we're at. We are now at 3 small checks, and the reason we need to get 4 small checks in order to get through our sensors module. And the reason we have one more module is because we actually have one more sensor on our tracker the way we've constructed it. We've been looking at the IR sensor in order to detect and avoid obstacles, but we also have a color sensor on here, and the color sensor is pointed directly down, and that's because we're going to use it to detect a line. So in the next video, what we're going to do is look at how the color sensor is used in a switch statement or a decision statement, and how we can set it up and actually detect a line and trigger some locomotion. So we'll do that next.